Our first man, Albert Einstein, came up with the four-dimensional theory of relativity as a young man to fix discrepancies between relativity and the electromagnetic theory by creating a thought experiment asking what a person hypothetically moving at the speed of light would see as they travel alongside a wave of light, as people thought light travels through a medium, which they called ether. Eventually, with his light experiment, they found that light travels through just space and time just based on their nature. Through this, though, he also found that time runs at different rates in different frames of reference, thereby showing that time is not static. He then stated that the mass of a moving body will increase without limit as the body's speed approaches that of light. All of this makes up the special theory of relativity where gravity isn't a factor. Eventually, this is summed up into the space-time continuum with time as the fourth dimension, up and down as the third, left and right as the second, and forward and backward as the first. Later, gravity and acceleration were considered the virtually same thing, creating the general theory of relativity. The more important addition, though, was that the laws of physics would be uniform regardless of the speed of time. He also found that light can be bent by gravity and that massive objects can curve space-time. Einstein made his own predictions on this to create his field equations, one of which is that, as stated in Britannica, energy equals mass times the speed of light squared, showing that the mass of a system measures its energy content. However, it showed also that if a body reaches a certain density, the solution produces a singularity or a 1D space, though we live in a 3D world with height, width, and depth, where certain math expressions become zero or infinite. Eventually, this added up with a study years later of the occurring process of when the nuclear energy reserves of stars run out, stopping hydrogen fusion reactions and causing their collapses, where J. Robert Oppenheimer actually found out that the larger ones turn into black holes with these properties, using the same knowledge to make atomic bombs. These black hole theories also made it possible for wormholes where one can travel across a galaxy in minutes, though they have not been known to exist yet. Though Einstein soon after retired due to old age, his place was taken by Stephen W. Hawking, who changed our perception of these theories, where one of the most important models, the fabric theory, shows how spacetime could be seen as a fabric that we all live in, that is bent by other celestial bodies. Another discovery he made was about Hawking radiation, making it easier to find black holes based off of radiation they emit at certain wavelengths. Lastly, he added to Einstein's theory that spacetime can be compressed. For example, 1 second on or near the event's horizon, or inescapable 1D part of a black hole, would be the equivalent of trillions of years on Earth, caused by the bending of time by gravity. Other achievements include the finding of a black hole in the middle of our galaxy that's holding it together in 2020. It's called Sagittarius A, and that we have now been able to take photographs of black holes. Thus, we end our trip on the history of astrophysics. Thank you for watching, and please ask real me any questions.